This video is going to pick up where we left off in the last video. So in the last video we had this function up here at the top, a prime b times b plus c, and we created the circuit that goes with the equation. The next step is to take the equation and see if we can simplify it to make a simpler circuit. So in order to do that, the first step would be to create the sum of products form. So if you go over, I'm going to do this over in Word. So to create sum of products is just that. So we're using our mathematical terms applied to these Boolean algebra equations. But basically what we're trying to do is we're going to create our variables multiplied by one another and then added together for each of the terms. So step one is expand to sum of products. And so we do that by distributing the complement of A times B across B and C. So we're going to just distribute that term. So A prime B times B plus A prime B times C. And so now you have the sum right here, the addition of the products. So these are your two products. Now the next step is to create the sum of minterms. So here we want to expand to sum of minterms. What is a minterm? A minterm means that you're introducing each variable into each of these terms. This is a term, this is a term. So to create a minterm, each variable must be introduced. So you can see your variables in the entire equation are A, B, and C. You have A, B, and C in this term. You do not have C in this term here. So a couple things. First, if we apply one of our Boolean algebra properties, we know that a variable times a variable equals that variable. So for example, B times B is going to be equal to B. If B were a 0, 0 times 0 equals 0. If B were a 1, 1 times 1 equals 1. So that rule applies here. So A, B plus A prime, B, C. So how do we introduce C to this term? If you look in your book, this corresponds with section 1.10. But the way to do that, you want to multiply by 1. Multiplying by 1 is the variable plus its complement. Okay? And again, just plug in numbers to test to see if that's correct. So if you had a C as a 0, 0 plus 1 results in a 1. And if C is a 1, you'd have 1 plus 0, which results in a 1 also. Okay, so that would be how we would introduce C with that term. So bring down the term you already have. Okay, and now expand. And you have prime B times C plus A, prime B times C prime. Bring down the term you have, A prime B C. Okay, so now another rule applies, A prime B C, A prime B C. These both exist twice, and you can have that if you apply the Boolean algebra property. You can have that number any number of times, that term any number of times, and it results in itself, so you only need it once. So that would be A prime B C plus A prime B C prime. Okay, now let's see if we can simplify further, and we can, because what I see in common here is A prime B, A prime B. So if we remove A prime B, we're left with C plus C prime, which is 1. And so finally, You're left with a prime b. So your function is reduced down to this equation, f equals a prime b. Very simple. Now you can see if you were to build the circuit for this, you only need 2 gates. You need your AND gate and you need your inverter. So let's go ahead into Cedar Logic and draw that very quickly. I'm just going to add text for this new function. Let's see if I remember it. F equals a prime b. And as I said, you need your AND gate. You need an inverter for A. Input A. Input B. Output LED. Connect all of these. And add your text for labels. Oops. Okay, much simpler. And now you can model behaviors, and notice when B is a 1, your output is a 1, which is exactly what was happening here, wasn't it? When B is off and A is 1, 0. So try that again. And you get the same output. So you can see that you've just simplified the equation. You're getting the same result. This appears to be correct.